Okay, so we're on 2022 paper 1, question 13. Now this is an arithmetic sequence question, and the formula for the sum of an arithmetic sequence is on the formula sheet, but in part A of this question we're asked to show that the formula is correct. So I'm going to remind you of the sort of the trick we can use to quickly add up an arithmetic sequence. So here's an example arithmetic sequence, it's got 6 terms. So the sum is obviously those numbers added together. And the trick we use is, if you remember, is to write the same sum in reverse. And what you note is that the terms which are sort of lining up with each other all add up to 17. So what you've got is 1, 2, 3, 4, 5, 6 lots of 17, but n lots of 17. But of course that is 2 of the sums, so the actual sum of the sequence itself is half of that. So that's where that comes from. Now, where does this? How can we work out that, you know, with this sequence the number you get would be 17? Well, let's instead switch to using more sort of algebraic, a more algebraic approach. So here's a sequence. So there's the first term, second term, third term, and the final term. So there's a big gap in here. Remember, to get from the first term to the final term, you add n minus 1, lots of d. So the sum of this sequence is just those added together. And I could write the same sum in reverse. I'm being really lazy here and only writing the first and the last term. And there's the pairs that go together. And again, in this case, although it's in algebra, it's the same thing. It's 2 lots of a plus n minus 1d. So what we're saying is the sum is that multiplied by n. Except that's 2 lots of the sequence, so it's half of that, which is what we're asked to show. Now, how do you show that in an exam? Well, I would say consider an arithmetic sequence where first term is a and common difference is d. This is, understood to be the formula. The notation for the sum. You could write the sum of that sequence if you want. I might, and I think I just do that and lasso it, and I think I might just do this, and then underneath do that. And actually, we've debated in the past, whether this would be good enough. I don't think you get full marks, but this is still good enough, isn't it? You could to get you some credit. So there we go. So that's the proof of the formula for the sum of an arithmetic sequence, and it is one of those things we're expected to learn, and in this case, it just happened to crop up. So hope that is clear.